Welcome to the Titus Timeout podcast. My name is Chris Griffin, and today I'll be discussing throw performance for grills and diffusers. To start with, let's define throw data. Throw is defined as a distance from the center of the diffuser to a point at which the primary jet is at a given velocity. You can see in the figure that the air leaves the diffuser, travels some distance, and at which point it's 150 feet per minute velocity. That distance from the diffuser is defined as the T150, or the throw at 150 feet per minute. That jet continues on and gets down to 100 feet per minute. That's defined as the T100, or the throw value at 100 feet per minute. In manufacturer's data, there are typically three numbers that are published: a 150 feet per minute, a 100 feet per minute, and a 50 feet per minute. Always check at the end of the table for the performance notes, because typically manufacturers will publish this in isothermal conditions, meaning the supply air is the same as the room temperature, but sometimes they could publish with a heating or a cooling value instead. Also, typically they are referenced to a testing standard, ASHRAE 70 of a particular year. You always want to make sure that you're looking apples to apples to make sure that you have isothermal conditions or ASHRAE standard 70 matching for different manufacturers. Now we're going to look at the significance of those three numbers. First of all, we're going to start off with 150 feet per minute and what is significant about that. Greater than 150 feet per minute, the jet is generally temperature independent. That is, the jet doesn't care if it's heating mode or if it's cooling mode. Since our catalog is published with isothermal conditions, you can use that 150 feet per minute value regardless of heating or cooling mode. At 100 feet per minute, there are a couple of significant properties. First of all, at or about 100 feet per minute, the buoyancy of the air can overtake the surface effect. By that, I mean that the weight of the air can overcome the surface effect. Whereas that's irrelevant for isothermal or heating conditions, a cool jet can separate from the ceiling and actually travel down into the occupied space where it can be felt as an unwanted draft by an occupant. The other significance of 100 feet per minute is that it can be useful in predicting cooling throws, as a 100 feet per minute isothermal condition is about the same throw value as a 50 feet per minute throw of a cooling jet. At 50 feet per minute, there's really nothing special about the performance of the air. However, the significance, as I mentioned a bit ago, was that it can be perceived by the people in the space. At velocities 50 feet per minute, they will notice the air movement. The goal is to keep the airflow in the occupied zone less than 50 feet per minute. That occupied zone is defined as heights up to 6 feet, 1 feet in from walls, and 3.3 feet or 1 meter in from a window. Don't forget to subscribe to our YouTube channel, and thanks for taking the time out with us.